Welcome back. So, let us examine the following problems. These are some of the more typical ones you might see. Which of the following integers are congruent to 3 mod 11? Now, we had established the following formula where we have if A is congruent to B mod M, then this works if and only if A minus B over M is equal to some K where K is an integer. So, this is basically the setup we're going to be thinking of when we do these problems. So, which of the following are congruent to 3 mod 11? So, I want to establish, does negative 311, is that congruent to 3 mod 11? Well, if this was true, then negative 311 minus 3 over 11 should be a integer or a whole number. So, negative 311 minus 3 is negative 314. Divide that by 11. So, negative 314 divided by 11 is, well, it's about 228.54. So they would not be congruent. Now, you could also be thinking, well, what if I wanted to find the remainder? What if I wanted to find the remainder instead of using that subtraction thing? Because isn't the modulo something like the remainder? Isn't that what we talked about before? But we have a negative number. How does that work? So, the way it works is you can simply do 11 divided with 311. Just keep it positive. And, well, I just want to show that this is not a part of the rest. And we'll just do this. Divide this out. So, how many times does 11 go into 31? Well, it goes in twice for 22. And, of course, we get that 31 minus 22 is equivalent to 9. Drop the 1 down, comes 91. Now, how many times does 11 go into 91? 8 times. And then we do the following subtraction. So 11 minus, or 91 minus 88. Make the subtraction 11 minus 8, which is 3. And that is going to be our remainder. So 28 with a remainder of 3. But that is when 311 was positive. But it's not positive, it's a negative. So what do? Well, if you remember, we can represent the modulo system in a cyclical way, where in mod 11 we start at 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the total possible values that we could have in the modulo 11 system. And from there, we can generate answers fairly easily. So, for example, let's just check 33. We could do 33 real quick. So I have to go around 33 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. And intuitively you might see that, yeah, that ends up at 0, of course, because 33 is a multiple of 33. But it is a way to find our answers. And since we had it out, we could use it to check. That was part D. So it is not congruent to 3 mod 11. It's congruent to 0 mod 11. But here I go going off track. What about this negative 311? I know that positive 311 has a remainder of 3, so that would be the same as 3. But what about negative 311? Well, in the negative case, you start again at 0, but you go back counterclockwise 3 spaces. So, negative 311 is actually congruent to 8 mod 11. And we can check that. We can easily check that by doing negative 311 minus 8 over 11. That would become 319 over 11. And this would be simplified to 29, a whole number. So, yes, indeed, we have that negative 311 minus 8 over 11 is an integer, so this congruence is true. But the original problem that I completely diverged off of was not true. So, with all that work being established, I'm going to run through B and C fairly quickly. We've already done part D. So, B, we would have to do negative 8 minus 3 over 11. Well, negative 8 minus 3 is negative 11 over 11, which is negative 1. So yes, it is going to be true. We have negative 8 is congruent to 3 mod 11. Now what about positive 8? Well, we would have to do 8 minus 3 mod 11. Well, I mean, sorry, jumping a little bit ahead. 8 minus 3 over 11. 8 minus 3 being 5 over 11. And we can immediately see that's not going to be an integer. So we have that 8 is not the same as 3 mod 11. Eight is not the same. So let's continue on with some more examples. Which of the following are congruent to 0 mod 15? So again, let's just... Well, one way we could also think about it is, like, we just have to find multiples of 15 in this case, because if we do write out, the work, -4 to check that this is true, we have to establish that -4 15 minus 0 over 15 is a whole number. But when the 0 is always going to go away, so it's -4 15 over 15. So what we're really doing is just checking, is it a multiple of 15? So 415 over 15 is not a multiple. It's about -27.66. So that is not true. And then we can just breeze through some of the rest of these. -75 over 15. Well, that goes in. 15 goes into 75 5 times, so it's -5. So it is true. It is true that -75 is the same as 0 mod 15. 25. Now, we should probably be able to see that 25 is not going to be the same, because 15 times 2 is 30, times 1 is 15. There's no way we can evenly get to 25. So 25 is not the same as 0 mod 15. 155. 155 divided by 15 is about 10.33. So we do not have 155 is not the same as 0 mod 15. And then finally, we have 555 divided by 15, which is equal to 37. So, yep, it's a whole number. So yes, we have that 555 is the same as 0 mod 15. And we can probably put together that, well, in any modulo system, if it's congruent to 0, it's just a multiple of that system.